So in today's lecture, we are going to discuss two numericals. Both are very important from the chapter Statistical Mechanics. So the question is the Fermi energy for sodium at temperature 0 Kelvin is 3.1 electron volt. Calculate its value for aluminium. It is given that free electron density in aluminium is about 8 times in sodium. So this is the question. So first we have to understand that what we have to evaluate or compute and which theory or formula is required for this problem. So we have to calculate the Fermi energy for aluminium. So first, what is given? Let us write. Given that Fermi energy for sodium, which I write as Na, and Fermi energy as Ef, is equal to 3.1 electron volt. And Fermi energy of aluminium, we have to find it out. Okay? And what is given? Number density or free electron density in aluminium is about 8 times in sodium. So the theory that is required, so if I write down the number density as N0, which is number density. So N0 is number density, which we can define as number by volume. So this is total number of electrons divided by the volume. Okay. So number density of aluminium is about 8 times of sodium. So I can write down, this is also a given condition, that number density, which is N0, of aluminium is equal to 8 times of number density of sodium. So this is another given condition. So what is the theory or the formula that is required to calculate this or compute the value of Fermi energy for aluminium? I required this theory, that is Fermi energy is equal to h square by 8m bracket 3n by pi v 2/3. So Ef is the Fermi energy, h is Planck's constant, m is mass of electron, capital N is the total number of electrons, V is the volume. So this is the theory that is required. So according to the problem, I will modify this theory. So I will write capital N by V as number density, and the formula changes to or modifies into Ef is equal to h square by 8m 3 n0 by pi to the power of 2/3. So N0 replaced by N by V. So N by V is replaced by N0, number density. So this is the theory which is required for this numerical. Okay. So this numerical or this equation I will write once for the sodium, and again I will write this, I will use the same equation and write it for aluminium. So for sodium I'll write this equation A. For sodium I write this: Fermi energy of sodium is equal to h square by 8m, 3 number density of sodium divided by pi 2/3, and I name this equation as 1. Again, I write for aluminium so Fermi energy of aluminium is equal to h square by 8m, 3n0 of aluminium by pi 2/3, equation 2. So equation A is the general theory which I replace for sodium, that is equation 1, and replace for aluminium, which is equation 2. Now what I do, I divide equation 2 by equation 1. So after division, what we have? We have Fermi energy of aluminium divided by Fermi energy of sodium is equal to all these constant terms, that is h square by 8m, 3 by pi, all this they cancel because these terms are constant for each of the equation 1 and 2. So we are left with Fermi energy of aluminium by Fermi energy of sodium is equal to number density of aluminium by number density of sodium to the power of 2/3. And we already have the number density of aluminium here. Number density of aluminium by number density of sodium is equal to 8, which I can write down as 8 by 1, which I can write down further as, because 8 becomes 2 cube by 1 cube, which is 1, then I can write 2 by 1 the whole cube. So I can replace this number density of aluminium by number density of sodium as 2 by 1 cube to the power of 2/3. So this 3 and this 3 gets cancelled, and I'm left with Fermi energy of aluminium by Fermi energy of sodium is equal to 2 square, which is equal to 4. As I have the Fermi energy of sodium value given, Fermi energy of sodium value as 3.1 electron volt. So I substitute the value of this. So I have Fermi energy of aluminium is 4 into 3.1 electron volt, which is 12.4 electron volt. This is Fermi energy of aluminium. That's it. So we are asked to calculate the Fermi energy of aluminium. The Fermi energy of sodium was given, and the number density relation between number density of aluminium and sodium was given, which is about 8 times of sodium equal to number density of aluminium. We use the theory between the relation between Fermi energy and number density, replace this theory with two different element, that is sodium and aluminium, and after calculation we arrive to the value of Fermi energy of aluminium as 12.4 electron volt. The second question that we have from statistical mechanics, the Fermi energy of silver is 5.51 electron volt. What is the average energy of free electrons at temperature 0 Kelvin? This is question number 1. Question number 2, what is the speed of electrons corresponding to the above average energy? And number 3, calculate the Fermi temperature. So what is given? Fermi energy of silver is given. So we can write down this is given. Fermi energy of silver 5.51 electron volt. And what we have to find out? We have to find out the average energy, that is E bar. Average energy, or you can say mean internal energy or mean internal energy. That we have to find out. So average energy question mark. Then speed or velocity, speed of electrons, which you have to find out, and Fermi temperature, that is TF, Fermi temperature. So to calculate the average energy, we have the theory or the formula to calculate average energy or mean internal energy, that is E bar is equal to 3/5 of Fermi energy. So Fermi energy of silver is given. Fermi energy of silver is 5.51 electron volt. So average energy of the electrons in silver is 3/5 multiplied by 5.51, which will give us 3.306 electron volt. That is the average energy or mean internal energy. So that's your question number 1. Then what is the speed of electrons corresponding to the above energy? So we know that this average energy that we have these electrons are using this average energy, the value is 3.306, and then they are using this average energy to have a kinetic energy which signifies or which hints to the speed of electrons. So when we talk about, or when we are asked to calculate the speed of electrons, the energy that is related with speed of electron is the kinetic energy. So the average energy is basically getting converted to the kinetic energy. I can say, better we can write out in this way, that the average energy gets converted to kinetic energy. This is the important part of the numerical 2. That is the second part of the numerical. The average energy is E bar, which is 3.306 electron volt, already calculated. This is getting converted to kinetic energy, half mv square. So that is your kinetic energy. So I know the mass of electron is 9.1 10 raised to minus 31 kg. So if I substitute the value of mass as this, I can calculate the velocity or speed of electrons, that is v. So I can write v square is equal to 2 into average energy, that is 3.306, divided by the mass of electron, 9.1 10 raised to minus 31. Now, if I substitute this, I get the value of speed, which will be incorrect. The reason is that when you have this left hand side, unit of energy is electron volt, and to have the speed of electron in or unit as meter per second, then you have to convert this electron volt into joule. That is, you have to convert this. So this is a special line, I can say. 3.306 electron volt to joule, you have to multiply by 3.306 into 1.6 10 raised to minus 19. Then this will give me in joule. So this is very important. So you have to multiply this 1.6 10 raised to minus 19, and the v square or the velocity square, or you can say speed square, you will get as meter square per second square, or speed in meter per second. So I have v square as, after doing this calculation, I have the value as 1.16 10 raised to 12 meter square by second square, and if I take the square root of v square, I get v. If I take the square root, I get v is equal to 1 10 raised to 6 meter per second. So this is the second part. The most important is to convert this unit of energy, that is electron volt, to joule by multiply with 1.6 10 raised to minus 19. The third part is to calculate the Fermi temperature. We know that Fermi energy is given 5.51. So Fermi temperature, TF, is equal to Fermi energy by Boltzmann constant. So Fermi energy for silver is already given 5.1 electron volt, and the Boltzmann constant, if I consider the unit of or the value of Boltzmann constant in electron volt, then I have the value 8.6 10 raised to minus 5 electron volt per Kelvin, and I have the value as 6.4 10 raised to 4 Kelvin. So that's the third part of the numerical. The Fermi temperature is given as, or will be computed as 6.4 10 raised to 4 Kelvin.